These sessions are going to show you how you can simulate digital circuits using MATLAB. When you open MATLAB, this is the window you will see. Okay, so this is the MATLAB command window. MATLAB actually has two parts to it. One is the programming that you can do, and the other side is on system simulations, which is the one that we are going to use for our simulation. So on the top here, you can see there's an icon there for Simulink. You can either click on that, or you can type Simulink in the command window, and that does the same. So if I press enter, that will load up Simulink. Okay, in here, in this window, Simulink start page, you can see that there is a lot of options. There are some templates for different type of projects or simulations that you can do. But we're going to start with a blank model. Okay, so we're going to use a blank canvas to start off our simulations. So if I click on this, okay, you open up your Simulink window. Let me just enlarge this. Okay, you can see that it is a blank canvas. So here is where you can drop components that you want to simulate. So Simulink is more of a system simulation, but you can also do simple digital circuit simulations and also electrical circuit simulations. Okay, so what I want to show you is how to get started to simulate a simple gate, and then you can use that as the building block to simulate your configurations of different combinations of logic circuits to work out the truth table, for example. So the components, so if you click on here, okay, you can see that is library browser. If you click on that, you open up your Simulink library browser. In my case, because I have used it before, so it actually go to the last icons or components that I have chosen. In your case, you most likely end up here, Simulink. Okay, you can see that there are drop-down menu here that have a lot of different components that you can choose from. So the easiest way to find your component is to do a search. So you can see that here on the top, there is a search box. So for example, if I want a gate, let's say NAND gate, just type in NAND and then click on search. You see that there's a list of different components show up. And you can see that there are two different menus where the components are listed. On the top, you have Simulink. There are 4 different components that has the same search word as NAND. And then down here, we have a SimScape. Okay, so here you can clearly see a NAND gate. And there's also a NAND gate here as well in the SimScape. But we're going to use the one in Simulink. So to take the component out, if you have done any simulations software before, it's very similar. So just click on the components to highlight it, and then hold on to your click. Okay, your left click, and you drag it out to the canvas, and then you release it, and that's where your components will show up in your Simulink window. Okay, so here I have an AND gate here. If I just go back to my browser, my library browser, the reason why I do a search on NAND gate rather than an AND gate, so if I do an AND gate search, you can see that the AND gate default block is a rectangular block with an AND, whereas a NAND is shown up as a proper gate. But I can click this and take it out just to show you. Okay, so this is an AND gate, but the block diagram that used here is a rectangular box with the name AND inside the box, rather than the normal AND gate symbol. But you can change it if you want to. So if I double click on this, you can see that icon shape, rectangular. If I drop it down, you can see that I can change it to distinctive. And if I do that, you can see that it will change automatically to the normal AND gate that you can recognize. Things that you can change, you can see that you have 2 inputs. You can change that to 3. Okay, so if you want a 3 input, okay, so you can type over 3, apply it. You can see that now the input has 3 inputs. If you want to have a 3 inputs AND gate. Okay. The other thing you can also choose, or you can change inside there. If I go back to my NAND gate, if I double click on that, if I want something else rather than an NAND gate, for example, if I need an OR gate, I can change it from here rather than find an OR gate in the library. Okay, if I click on OR, apply, it will change to an OR gate. But because originally when we take this out, it was a NAND gate, the name itself hasn't changed. We still name it as a NAND, but this name doesn't affect your simulations. But for convenience, or not to be confused, you can change this. You can click on it and then type over it to change it to an OR gate. Or if you want to name your device properly, you can, if you have a lot of different OR gate, you can call this OR gate 1. And then let's say, if I want to duplicate this, I can hold on to my control, my keyboard. If I keep on, press on control, and then click on this, and then drag it away, it will duplicate. Okay, because I named this 1, so now this automatically become 2. Okay, so that's how you can duplicate this, or you can just right click, and then you can copy and paste that also duplicates the components. Okay, so that is how you can put components onto your Simulink. Again, let me delete all this, and then I'll start with my OR gate here. Okay, so to simulate this OR gate, so you need to have an input and output. to your OR gate. So just like what you did in the lab, so you put in switches with a voltage to the gate, and then you display the output to an LED. But here we're just going to apply voltage to the input and then display the output on the display. So if I go back to my library browser, and then I go back to my Simulink menu, you can go down here. You can see that there's a sub menu here called source. If I click on that, you can see that there's many different source components inside here. So to start off with, we're going to choose a constant source. So if I click on this constant, take it out to my Simulink window. Now I can connect this onto my input. Okay, so to wire it up, I just point it to the port of my source, click on it, or onto my click, and then drag it to the input port of my OR gate. Okay, so you can see now it's wire up from the source, the constant source, to the input of the OR gate. And then let me duplicate this constant source. Again, hold on to my control and then drag it down. And then wire this again. So we have two sources, one on the top, one on the bottom. I can rename this. I can call this A. I can call this B. Okay, so I've got a source A and a source B, or in Boolean, this will be my Boolean variable. I also can name the wire. So if I double click on the wire, I can also label this on the wire. Put an A there. I can put a B there. Then I can change the source value. So by default, it shows 1. So if I double click on the 1, I can type 2. Actually, you're just going to do 1 and 0. Okay, so I can put 0. Okay. Or if I click on this, I can also change it directly here. Okay, so now I have my input as 0, 0. So I want to be able to see what is the output of this gate. So if I go back to my browser, so instead of source, I now choose sync. Okay, so in sync, again, you can see many different components here. In this, because we're dealing with constants, you can choose a display to show what's the output of our digital gate. Again, wire up, click on the output port, drag it, and put it to the inputs to my display. Okay, so in this simple setup for an OR gate, we are ready to simulate to work out what is the output. So in our simulations, you can see that the simulation time shows as 10 seconds. Because everything is constant, it doesn't really matter how long you run the simulation. So if you put it longer, just going to wait longer, but it doesn't do any additional things for you. So for this simple example, I can make it into 0.1 seconds. Okay, so for 0.001 seconds, it doesn't make any difference. Make it longer, you just have to wait longer. Okay, so once you've done that, just click on Run, and it will simulate, and then it will display the output on the display. So we have our OR gate 0, 0, give us 0. If I want to change it, let's say I want to go through my truth table, change this to 1, and then simulate it again. Let me put this to a smaller value so that it doesn't run too long. Okay, show 1. Okay, 0, 1, OR gate, output is 1. 1, 0. I'm sure you know the answer. The output will be 1 also. I'll put it to 1, 1. I'll get 1. Okay, so there's one way you can simulate and work out the truth table of your combinations logic circuits. I can change this gate if I want to. Let's say I want to investigate what is the truth table of an NOR gate. Exclusive OR, applied. And I can run this 1, 1, give me 0. Okay, so that's one way of doing it. Another way is with timing diagram. Okay, I briefly talked about timing diagram in class not too long ago. So if you can create a timing diagram that have all the combinations of your A and B, then you can have the output. So it will be your truth table, basically. So if you can include in the timing diagram A and B to have all your combinations, then you can have the truth table display out as a graph. Okay, let me show you what I meant. Okay, so we have A and B. So normally we draw our truth table A, B, and then we list down all the possibility going from 0, 0, 0, 1, 1, 0, 1, 1. Okay, so that lists out all the possibility in our A and B variables. So if you look at B, the values go from 0, 1, 0, 1. Then A go from 0, 0, and then 1, 1. Okay, so we can use time varying signals to represent these patterns. So if I got B, I can use a rectangular pulse that goes something like this. Okay, so it has a value 1, 0, and then a fixed timing. Let's say 1 second, 2 seconds, 3 seconds. So every second, the pulse changes from 0 to 1. Okay, and then I can have my A that do this. So it changes every 2 seconds for my A. And therefore, you can see that within this first second, we go 0, 0, and then between first and the second seconds, we go 0, 1, and then between second and the third seconds, go 1, 0, and then third and the fourth, go 1, 1. So basically, these patterns give us the inputs of all the possibility of A and B. And then the output of the gate will be F, and then F will be whatever the outcome that you get from the outputs of the gate. Okay, so if you can set up the inputs as some sort of waveform that changes with time with these patterns, then we can display the truth table at the output. Okay, so let's go back to our Simulink and see how we can do that in Simulink. Okay, let me delete off this constants inputs and the display. I'm going to replace it with something changes with time. So go back to my library browser, go back to my source, and then go further down. You can see here we have a pulse generator. So if I take this out and connect it to the inputs, then I need another one of this. Okay, let's rename this as A. This as B. You can also name the wire as well. If I double click on the wire, you can call this A signals, and then this B signals. Okay, so before I show you the output from the OR gate, let's look at how this rectangular pulse actually behave. So to do that, I can go back to the sync, and then I can pick up a scope. So this scope will work just like your oscilloscope in the lab. Okay, so at the moment, the default, this scope has just one input. You can change the number of input to be displayed on the scope. Okay, so if I right click, you can see that there's a list of menu. We show signal and port. I can change this to 2. Okay. I think some version work differently. Some version, if you right click, this signal and port doesn't list on this menu. So in that case, if you click on it, and on the top menu here, you can see simulation, debug, modeling, format, add, and here you have a menu on scope. So if you click on that, you can see that the number of ports is displayed up here, which you can change it. Let's say to 3. You can see you change to 3. So let's do 2 at the moment. So I can connect the first one to A. And then I can connect the second one to B. Okay, this is the default. I haven't changed anything yet. The stop time. Okay, now it's important because our rectangular pulse is changes with time. So if I click onto this to to look at what is in the default, you can see that the default has an amplitude of 1, a period of 10 seconds, and a pulse of 5% of period, and a delay of 0. So in order to display the whole pulse, we need the simulation times to be at least 10 seconds. So let's see how this pulse looks like. So it's the default for both at the moment. So if I go back to my simulations, if I change my simulations time to 20, then I'll be able to see 2 pulses. So if I run this, okay, and then I double click on the scope, so it shows up the signals of my pulse that generated by this pulse generator. The default setting is amplitude is 1, the period is 10 seconds, so which means that this pulse repeats every 10 seconds, and then the pulse width is 5%. So meaning that the pulse is going to be on or high for a period of 5% over the period. So the period is 10 seconds. So 5% of that is half a second. So it turns on for half a second. So for our purpose, we want the pulse to be 50-50. Okay, so it turns on for half the period and then off for half the period. So we need to make some adjustment to this pulse generator. Okay, let's do the A one. So now the A pulse, amplitude 1. It doesn't really need the period to be 10 seconds. For easy manipulations, I keep it as 1 second and want the pulse width to be 50%. And then I apply it. Okay, not changing B yet. So just going to see what that looks like. Okay, so you can see that A, to differentiate the two, we can put a legend. The yellow line show is A, the blue line show is B. So now we change it to 50% with a period of 1. So we simulate over 20 seconds. So we get 20 pulse. Another way to display this is overlapping. We can separate the two graphs. If I go to View, Layout, and then I put it into 2 rows. Okay, I can separate the 2 graphs A and B. So you can see that A repeating 20 times because the period is 1 second. So every second we got 1 pulse. B, we haven't changed it, it's still the default, so the period is 10 seconds. So we got 2 pulse there, and then it turned on 5%. And the other thing is the timing diagram I showed just now for A and B, we want it to start at 0. And the default in this pulse is starting at 1. Okay, so you can see that at 0 time, the pulse is 1. But we want it at 0 time, the pulse to be at 0 and only rise to 1 in half the period. So to do that, we need to shift this pulse by half the period. Okay, so if I go back to A, you can see that there's a phase delay in seconds. Our period is 1 second, so we want to shift it by half the period. So it means that I want to make this 0.5. Okay, let's change this as well. Make it into 1 second. And then 50%. And I keep this at 0 phase to show you the difference between the two. And then run for 2 seconds so that I have 2 pulses. Okay, you can see the difference. So the top one, I have changed the phase to shift by half the period. A is the default without shifting. You can see that A is now starting at time 0, 0, whereas B at time 0 is 1. And the A1 is the one that we want. And then if we change the period of the pulse accordingly, we can create the timing diagram for A and B that I showed just now. Okay, so if I can make A to have period of 2 seconds and then B to have a period of 1 second, then we can create all the possibility for A and B, just like your truth table. Okay, so I go ahead, change this to 2 seconds. And then my delay, I want it to be half the pulse, which is 1 second. And then B, 1 second, and then delayed by half a second. Then count it. Okay, so you can see that now it is exactly the timing diagram that I showed just now. So between 0 and 1 second, we have 0, 0. Between 0 and half a second, I got 0, 0. Between half a second and 1 second, I get 0, 1. Between 1 and 1.5 seconds, I get 1, 0. And then between 1.5 and 2 seconds, I get 1, 1. Okay, so this combination of inputs, we have listed down all the values of A and B. And if I read what is in the output, that will be equivalent of showing the truth table. So to put my outputs onto the scope, I need another input to the scope. So let me change this to 3-port. Then I can now connect this. Okay, so I've got now A, B, and then so depending on what you want to call the output, maybe I can call it F, like the one I showed just now, which is the output functions. So if I run this, okay, so the output is overlapped onto the second graph. Again, I can split it. Okay, so that shows A and B is the input value, and then F is the output value. So I've got 0, 0, give you 0, 0, 1, 1, give me 1, 1, 0, give me 1, 1, 1, give me 1. Okay, so this is basically your truth table. You can change the gate if I want to investigate a different gate. Let's say, let's look at an exclusive OR. So this is the display or the truth table of the exclusive OR. Okay, so we got 0, 0, give us 0, 0, 1 give us 1, 1, 0 give us 1, and then 1, 1 give us 0. Okay, so that is how you can simulate logic gate in Simulink. So to build a combinational logic circuits, you just combine the gates that you want and then interconnect them and then create the right timing diagram for them. Then you can work out the truth table of your combinational logic circuits.